Graphs involving modulus functions. We know that a modulus function always returns a positive value. Consider applying this to a graph, such as this graph here. Think about how we plot a graph. We input an x value, and we get a corresponding y value, which means we plot this point here. Now, if you have a modulus around the outside of your function, you're not going to get these values down here. You're not going to get any negative values. Instead, you're going to return a positive value. So the parts of the graph that are above the x-axis, which have positive y values, will remain the same, but this section down here will end up being reflected upwards like so. So we'll follow the red here, then the blue around here, and then the red up this way. And now, as a second example, consider this one. So all of the parts of this that are above the x-axis will be fine. But where it goes below, it must reflect upwards. So in other words, this will go up like this, and we'll lose the part down here. And the same thing here. It will reflect upwards here, and we'll lose the bit below. So the graph will look like this, following all the red bits that are above the x-axis, but following the blue bits for the parts where the red curve was below the y-axis. So this would be the graph of the modulus of whatever this function was. The basic modulus function graph is the graph of y equals mod x. So what would that look like? So let's have some axes for our sketch. So x-axis, y-axis, and then think about the line y equals x without the modulus. So y equals x looks something like this. So this is the line y equals x. Now, following on from what we've done before, down to the origin, everything is above the x-axis, so that's fine. But when we get to the origin, just here, we then have the situation where the line goes below the x-axis, and if we have a modulus around the outside, that will return positive values instead of the negative values we've plotted here. And so it will actually reflect upwards, and we lose this bit. So y equals mod x looks like this. It's still y equals x along this section, but this section is actually part of y equals negative x, and it just has a sort of right angle turn here at the origin.